having me here. As you said, I'm head of product management at SAAB for our fighter radar systems and what we call core platform or core sensor core area. And I will tell you much more about what we mean with our platform development and sensor core area, because that's one of the parts that I'm going through today. I've been working at SAAB for well, quite a few years right now, 12 years I think it is, and before that I was at Volvo Cars for a couple of years and also Volvo Trucks for unfortunately only a couple of months actually, but still I've been there. It's a very exciting company as well. But today a very long title, New Security Demands Gives New Possibilities, Transformation from Legacy-Based to Platform-Based Sensors. And the transformation that I will go through is something that we already heard Jan talk a little bit about in his first speech today, and this is a topic that we will come back to often in these sessions regarding software center and digitalization. But still, first, just to give you a small update on what's SAAB, and bear with me, it's just 3 slides, I think. So, but it's a international defense company where we produce and develop products and solutions to create our vision, and the vision is keeping people and society safe. We are around 18,000 employees worldwide, and we have customers in around 100 different countries. We have development sites in some countries, United States, United Kingdom, Germany, Sweden, Australia and Finland, and probably some new countries which aren't on the map as well. So we're turning from a traditional, or we're seen maybe as a very, very Swedish company, but we're increasing our international expansion more and more. And that's an important part. And our different core areas to utilize or to realize the vision is advanced weapon system, where we have in Dynamics and from Bofors. We have, of course, the aeronautic parts, where the Gripen platform is the part where most people, what they think of when they hear SAAB, or maybe the car as well. That's still quite common, even if we separated, I think, in 1992 or something. But still, you get some questions sometimes about the SAAB car, but that's fine. So it's fine. And command and control, we do some different systems for command and control of ships, and even in civil security for harbors and traffic management, as the picture shows there. Underwater systems for it's both large submarines, as on the picture, but also unmanned underwater systems for different topics. And of course, the main part, if you ask me, the sensor systems, because that's what we work with in Gothenburg, up in Kallebäck, where we are approximately 1,300 people, I think, today in the office up in Kallebäck. And we develop sensors, both air sensors, for instance, the fighter sensors sitting in the older version of the Gripen fighter, for instance, and also the sensor suites that are presenting on the picture there for land-based radar systems, but we also do naval-based radar systems, and a lot of other different kind of smaller sensors as well. And how have we come to the point where we are right now? What's important to keep in mind going forward? And definitely the bullets, the third and the fourth bullets in this slide is important to keep in mind while I go forward in this presentation as well. But we have efficient solution for safety and security. We have both airborne and ground-based naval radars and solutions. But high performing, that's one of the major points where we are right now, with a broad customer base and then the profitable operation. Our system are known for being compact and easy to operate for the customer. They don't need a big surrounding or big service accompany the product. It's very maneuverable and easy to operate. And can be integrated easily to the customer's existing solutions. And that's one of the things to keep in mind when you talk about platform-based products and to streamline the product. How can you keep the customer point of view to easily utilize them in their systems? And the cost-effective system, local presence and through live service and support. And the live service and support is, of course, one other important part, talking about software development, for instance, and how we will handle that in the future. But traditionally, when you are a defense company working with defense industry, you talk about the traditional warfare, which is shoot the most, shoot the longest, blow up things and so on. But the traditional has been substituted to a more a future warfare where the information leverage is crucial. And you can see this in the ongoing conflict in Ukraine, where the information is more and more important. And if you cannot rely on the information you get, then you don't know which decisions to take. So our census is one very, very important part for the customer to realize or to use the information needed for them to take the correct decision with their assets. So the information give them a leverage and an additional value, which will be even more important going forward, because as the title says there in this speech, we have some future threats that will give us some benefits regarding the transformation to continuous values and all the parts we're talking about here. But I won't go through all these bullets, but as you can see, the technology steps that you take in all kinds of different areas regarding speed, regarding stealth, and that's low observability of the targets for a radar system, and different kind of ECCM, that's electronic counter measures. So that's, for instance, how you in the radar system handle jammers or high power disturbers. And all of these threats requires you to increase your own ability to handle them. And I just put one extra picture down here in the right corner, where I found in Göteborgs-Posten the day after the Russian invaded Ukraine. And it might be a little bit difficult to see in the picture, but up on the hill there's a long-range air surveillance radar system. So this was the first target of the Russian strikes during the first nights. So that's just underlines the importance of these sensors for the customers. So it's really happening. And cyber warfare, of course, that's the last bullet says there. If you have these kind of sensors, you must know that you can rely on the information you get from them, and that they are up and running wherever you need them. So the cyber warfare and the cybersecurity is very important. And then, just as all other companies, we have, of course, competitors to handle as well. Even though the focus is, of course, on the customers, but we have might be some kind of signs of a disruptive market change, where it's easier to buy a complete set of AD and DA conversion built in one component. And of course, if you have enough knowledge with a smaller business, you could develop a sensor quite easily. At least to get to the first fail fast point, that might be quite fast. And then, of course, the system of system, where we have traditionally built up our business in a way where they are used in a certain type of way during the operations the customer use. But when we're talking about drones and information warfare and all the other buzzwords I had on the other slides, then of course it might be very crucial for you to build a new system of system integration instead. So these two types could disrupt the market, and we need to keep that in mind. But as I said, these threats to our customers and to the system we develop can also give us new opportunities in terms of our digitalization as a company and our agile business. Because the radar system that we develop will still be a backbone of the military information systems, even in the future. And even if they will maybe be smaller and have more in a number of more systems, they will still be very important parts. But you have new requirements, and that's, for instance, traditional radar performance of range and SWaP-C, that's size, weight, and power and cost. And that's always important, of course. And then you add some other requirements of stealth to be able to identify and to see stealth airplanes or other or stealth ships, for instance, or other objects you would like to see with a lower radar target area, and passive functionality. And that's also that since the systems are very important for the user, then it will be very beneficial if you can have a passive mode, and that is that you don't transmit any RF energy, you only receive. And in that way, you are much more invisible for the opponent. But then cybersecurity, as I mentioned, that is today a very, very important part for us, but it will be even more important going forward. And we have what's called KSF in Sweden. That's krav something for sekretessfunktioner. Krav för sekretessfunktioner. Something like this. And STIG is the KSF is from the Swedish Military of Defense, the MUST. And the STIG is the similar, but from the American Military of Defense instead, or Department of Defense, sorry. And this requires us to be continuously accredited towards these standards. And that's, of course, well, might be a bit tricky today and will be tricky tomorrow. But well, with software and DevOps, this is something we could handle. And of course, continuous deployment, and to make sure that we cope with the international standards that are increasingly evolving in around the globe. But during the last maybe 10 years, we have taken large steps in our hardware development to have a platform where we could actually add on this functionality needed forward. We have GAN ISS, and that's well a way to have very high signal integrity or low noise transmitters and high energy efficiency in the radar system. And then multifunction in different ways. Well, we already have it in the systems and additive manufacturing. So the future lays instead in software. And that's when we talk about software, it's software-defined radar. So you can have an agility in waveforms and in functionality. You can swap between those in a very agile way, depending on how you would like to use the system. Cybersecurity, as I mentioned, and of course the development methods will be very, very important to handle and in order to speed up the development and the delivery of the solutions as fast as they will be needed. And all these together will help us to do something that we aimed for was it 11 years ago? We started with the software center. And one of the main topic there was to transform SAAB as a traditional mechanical company into a modern data-driven software company. And we have definitely taken some large steps towards that goal, or towards a vision maybe. But these requirements or these changes that we've seen in the world the last few years will help us increase, will give us some new tools for development. And we have had Helena and Jan with us for quite a few times, talking about business agility and software-driven business. And of course, if we look at some bullets here, the transition from transactional to continuous business model, as Jan talked about earlier this morning, is something that we're aiming for. And by the slides coming right behind these, I will show more about what steps we're taking towards this. But this is what we aim for. And also becoming a software company. And the staircase in the bottom there from 0 to 5 is one model of how to transform and what steps and measures that you must take in order to actually call yourself a software company. And these are the steps that we in our software development and in our teams, we are having a key performance indicator to measure and to monitor. How are we doing in this? So that's the way we handle it. But I'm talking a lot about software and radars and sensors and so on. So I just wanted to give you a little insight in what this is and what we actually work with regarding software in our radar systems. So this is a typical model of a radar system. We have an antenna, a signal data processing, and some command and control unit. Once you collect data, RF information from the antenna, you analog to digital convert those in the signal data processing unit, and you get some raw video data. And after the signal processing, you could extract some targets or plots that are some points of interested information in the space. But that might be birds, and that might be houses or cars, or a lot of different things, or windmills. Is that or a lot of different other things that you actually don't want to look at. So therefore, we have a tracker algorithm that determines if this is a bird or a UAV, or if it's a large airplane or a house or whatever. And you also predict the trajectory of the object to be able to be more certain that, okay, this is actually a bird, let's get rid of this part. No airplane can fly like that. And then, of course, you have the command control software for the user interface as well. And when we talk about software at SAAB, we have all the different software layers actually that we develop, all the way from the hardware layer with FPGAs and microprocessors in VHDL, yeah, and up towards the platform layer where we have runtime OS, and we actually develop our own OS for some cases, but we use Windows and Linux as well, and configure those systems. We have middleware layer for frameworks, and the application layer, which actually was the last slide I showed you, where the magic happens. But of course, as you all know, the other parts of the software is just as crucial, otherwise you won't get some effect. And user interface. So the software development is quite broad. So we have some internal problems because many people still say that, are you working with software? And that's a question that you really can't answer because it's so broad. What do you mean by it? But we are in this transformation from a traditional way of working with the waterfall and legacy-based development. So these are just some pictures illustrating our different kind of radar system we are deploying. And the traditional ways of working, I just want to make sure the clock here. The traditional way of working is that you take some parts of the code from for instance, from the Arthur and Duroff A and B from the left corner in the picture, and you use that for another kind of system going forward, and then you use that part in another system. But you don't reuse any verification or any integration or actions. And this requires a lot of work to actually go from one product to another. And that's not the only issue, because in real life it looks more like this. Because there tend to be more than one customer for each system, and the branch just increases. And this looks, of course, good from a business selling perspective, but from a resource perspective, this is well, killing us. So it's very difficult to find and to keep a business and to find people enough to support this setup. So as many other people, many other companies, we're working on a model for platform-based development instead, where we have a roadmap-driven architecture. And instead you have this platform base going towards a goal that are set up in roadmaps, and you actually reuse actual components or building blocks that are integrated with each other. You have standardized interfaces, and you reuse verification. And by doing that, you could still build up all these kind of different systems during our sustainability phase, but in the meanwhile, you are going forward towards the future product generation as well. And of course, all the other benefits of not having the branches and to deploy more regularly and continuous. And then in our case, as a company within the software industry, the defense cloud compatible will be crucial as well for the software development in the future, or for the system, maybe I should say. Yeah, and I think I will skip this picture, and the network is really
not optimal.
It's not optimal. No, but still. Anyway, we also have a model with speed layers. We talked about different layers earlier, but that was in another context. This is from a technology, market and sales driven layer point of view, where we have product roadmaps and technology roadmaps and strategy documents from within SAAB, where we gather information to make sure that we take the right decisions in our roadmap. And you take some bigger, larger steps when the technology is ready, or when you see that the market is require you to do some steps. And you put these building blocks out there on the output, lastbrygga. I don't know if anyone knows an English word. Delivery, yeah.
I don't know.
You make them able to deliver, and you release these on cadence. So this is our internal life, like a clutch. We extend them from the market, from the sales parts of the system. So you put these building blocks, and then you increase them as an input, or you put them as an input in the sales-driven layer, where you actually take customer requirements, configuration, specifications, and test plans to build to configure these building blocks into something that you could reuse in a couple of different system products, as the picture shows. Okay, sounds easily, right? Very easy. But where are we now in this work, in this transaction? We have been looking at the Balfour model again, together with you, Helena, and Jan, and other, and we have increased the new organization built on this model, more or less, with the responsibility to drive this transformation and to define the platform-based products. And that's where I'm working right now. We have identified our platform products from where we will build the deliverable customer systems. And the system application is, of course, a very crucial part. And Anders, the gentleman right next to me, is working exactly with that part, with the sensor application platform. And we have a governance structure of how we should handle this internally in terms of R&D funding and reporting and all these parts that are needed to be in place to make things happen in a bigger company. We have safe inspired teams launched, working with the development within the platform products. And we are doing a major investment in our development environments. And that's, it's driven from a safety and security perspective, but we are, of course, gaining from this perspective as well. So it's really happening. Something. But I didn't say the negative part. That, of course, as other companies were struggling with long-term profit versus the short-term objectives in contracts already sold. So that's, of course, something that we need to balance in our everyday. And by that, I think this was what I was planning. So this is the SAAB platform strategy.
For everyone in the room.
Thank you.
Thank you, Niklas, for, I think, a really interesting presentation. And I just have to ask you one thing before letting everyone else in. I have recently and am involved in work with many of the software-centric companies that are moving towards one platform, or at least more of a platform thinking, to avoid exactly what you showed in terms of resource allocation and, customer customization just explodes, and you would really want it to be more on the configurations derived from this platform, that kind of mindset, which then I think is much more than the technical solution. Also, you move from more of a project or product mindset towards this, you present the platform mindset. Yeah, the roadmap mindset. Yes. What would you say? So if you mentioned it already, but at SAAB, how did you experience this? What were the key challenges in the organization to get to this roadmap, the platform, Well, I think it has been, and it still is, the major challenge is to handle the short-term objectives. Because we have been very successful in selling our system the last 5 years, and to have enough resources to both work with those configurations that are contracted and to make this happen. That's a major issue. And the other part, I would say, is to make the developers or the engineers to understand that we will not continue our traditional ways of working to reuse code, but instead we will build building blocks, verify them, and make sure that these are possible to reuse as a whole. Mm-hmm. And that's still something that we work on. Mm-hmm. Thank you. Anyone? Sami has a question.
Oh, thank you for the presentation. I will start with quite kind of technical question. But isn't your approach more prone for security vulnerability, I can pronounce that, security weaknesses if you're having the same platform for all products. So if you have one weaknesses, then it will be in the all product. So wouldn't the old one be more secure today?
Yeah, I would say so. If you, because then you immediately come into the important part of the architecture. How will you define or build up the system architecture of these products? And that's, of course, if you manage the system architecture in a correct way, then you have, I would say, a much bigger. Yeah, you will succeed easier if you have a platform-based approach. Yeah. That is, yeah, you verify it and you make sure that the surrounding is working with it.
Are there other questions? Yes.
My name is Lars Persson. I'm from Volvo Cars. But for your sake, I could say I was working with a signal processing for the first giraffe radar.
Okay.
In the 1980s.
Okay.
So we're going the opposite way.
Yeah.
But we're struggling with the same thing in Volvo Cars and working with embedded systems with many components. It's a challenge to keep everything in a platform. Because you have unique components in almost all product families. So how have you targeted that? Are you keeping all parts in the platform development, or are you branching off for a product family with certain specific components, or how do you treat it?
Well, the strategy is to be more more in one corner for the next generation of products, where it's easier to build up the architecture to make sure that you have all the components reusable. That's for sustain of the older system that you mentioned, for instance. Then, of course, you have the legacy that you must handle in some way. So there you more have an approach for when it comes to obsolescence. For instance, you could restrict some components, hardware components with some software blocks in it, or you could add on some of the new developed components that will be used in the future products as well. But we have a number of legacy products that we still must handle for quite many years to come.
But you intend to use the platform development also for those?
Yes, in all way possible. Yes, but it's well, how much will be possible? That's still something to sort out. Yeah. Okay, thanks.
Are there any questions from the people online?
There is at least one in the chat.
In the chat.
Oh, it's me right now. You have.
Could you see the question, Meno, in the chat? Is there one?
Yeah, have you considered dividing into separate teams, focusing on internal module development and other teams working on customer implementations separately? Yes,
that's a very good question, and actually that's more or less what we're doing. Because we who are working with the sensor-based or the platform development is more or less one team or a couple of teams working together, and then we have. In our engineering department, we have many more teams working with the legacy products that we talked about. So in some sense, they are and will be divided for quite some time. But we'll see. In the end, of course, we would like to have one platform. But our system, they will be used for 20, 30 years to come, the ones that we have delivered today. So we must have a setup working in both ends.
Thank you, Menu, for reading out the question, and Sami for putting my attention on the chat. Any other questions? Rita?
Yeah, I'm interested maybe more at the organization level. So you've 38,000 people, you've got 6 or 7 different sites, countries, presumably within each country there are lots of sites. So I'm wondering, A, how do you manage to change, 38,000 people's mindsets? And B, I'm wondering from a global software development perspective, did you hit on any issues around the fact that everyone is everywhere?
Yes, and we have started more locally in Gothenburg and in Sweden. So I'm working, mainly the main effort is put here in Gothenburg to make the site here in Gothenburg with the 1,300 people understand and want to be participating and to develop this model together. So that's the first step, so to speak. Then we have a site in Stockholm, which is approximately the same size, and they are doing something similar with their system. They're not developing a radar system, but other electronic systems. So we are trying to cooperate and to help each other. And then we have done it in Sweden, and then the next step will be worldwide. But in terms of development, I don't have the exact figure or percentage, but it's more like 90-95% of the development is in Sweden.
Okay.
Yeah. So if we succeed here, we yeah.
You're on a good way.
Yeah.
Yes, Sami.
Yeah, this is not right to your presentation anymore, but given your title, I'm interested on your viewpoint. In Finland, there is ongoing discussion, should a product manager have a technical or business background? And I think you are in quite unique position. So what is your view? Should your product managers have business background or technical background?
They must have both.
Okay.
very...
In Sweden, we do both.
Yes. No, but in our business, which the technical issues are very in forefront all the time. So I would say it's more important that you have a technical background. Yeah. If you have to choose, I would say the technical background.
Also kind of assuming that in your field. So. Yeah. Thanks.
With
that people are more likely to cause problems.
Yes, we wanted to have the problems first, find them fast, right?
With that question, which is also very interesting, business versus technical, or rather, how do we merge and combine the two? I think we could go on forever, but in the interest of time and the schedule and the